In the cosmic abyss, the weight of black holes, a wondrous chronicle of time, an era that unfolds, strokes of light, the touch of darkness, mysteries embedded in the past, secrets of the future's harness, the cosmic dance floor, a ballet of starlight, silhouettes of time, our steps in the night, a dazzling night sky, a stage of enigma. We are but a chapter in the living universe's drama. Today, I will introduce an alternative theory to resolve the paradox of black hole information known as the holographic principle. This principle, independently proposed by Gerard 't Hooft and Leonard Susskind in the 1990s, suggests that the event horizon of a black hole plays a role similar to a hologram. In holography, a two-dimensional surface encodes a three-dimensional image. Observing the surface of a hologram allows us to perceive a three-dimensional image. According to the holographic principle, the event horizon of a black hole is analogous to a two-dimensional surface. This surface encodes all the information generated within the black hole's interior. The holographic principle is considered crucial in resolving the paradox of black hole information. This paradox arises from the contradiction between the need to preserve information of objects falling into a black hole and the fact that information cannot escape from the black hole's interior. According to the holographic principle, all information generated within a black hole is encoded on the event horizon. Therefore, when a black hole evaporates, the information encoded on the event horizon returns to the universe. The holographic principle posits that spatial volume can be considered an encoding of information on the lower dimensional boundaries, such as the boundary of light. This principle is a theoretical postulate of string theory and a presumed property of quantum gravity. In the context of black hole theories, the holographic principle plays a significant role. The event horizon of a black hole is considered a two-dimensional surface. According to the holographic principle, all information within the black hole is encompassed on this two-dimensional surface. The holographic principle holds promise in resolving the paradox of black hole information. If all information of a black hole is encoded on a two-dimensional surface, then when the black hole evaporates, this information can return to the universe through that two-dimensional surface. ADS-CFT duality. ADS-CFT duality, proposed by Juan Maldacena in the 1990s, represents a duality between a five-dimensional anti-de Sitter space, ADS space, and four-dimensional conformal field theory, CFT. ADS space is a five-dimensional space with negatively curved space-time, while CFT is a quantum field theory occurring in four-dimensional space-time. This duality plays a crucial role in understanding the thermodynamics of black holes. Black holes are considered to play a role similar to the boundary of ADS space in the context of ADS-CFT duality. Therefore, using ADS-CFT duality, we can gain insights into the thermodynamics of black holes. ADS-CFT duality is closely related to the holographic principle. According to the holographic principle, the volume of three-dimensional space-time can be encoded on a two-dimensional surface. ADS-CFT duality provides a method to implement such holograms, while ADS-CFT duality is not fully understood. It is believed to play a significant role in the future study of black hole theory. ADS-CFT duality corresponds to the relationship between anti-de Sitter ADS space and conformal field theory CFT. ADS space is a 5-dimensional spacetime with negatively curved geometry, and CFT is a quantum field theory with a 4-dimensional boundary. ADS-CFT duality serves as an example of the holographic principle. The information in ADS space corresponds to the information in CFT. Thus, ADS-CFT duality aids in explaining the holographic principle in black hole theories. ADS-CFT duality can also assist in resolving the paradox of black hole information. According to ADS-CFT duality, information within a black hole is contained in ADS space. Consequently, when a black hole evaporates, this information can be transmitted to CFT through ADS space. The significance of the holographic principle and ADS-CFT duality in black hole theory. The holographic principle and ADS-CFT duality play crucial roles in black hole theory. These principles can potentially help resolve the paradox of black hole information. Additionally, they may aid in understanding the internal structure of black holes. While the holographic principle and ADS-CFT duality remain theoretical and not completely understood, they are expected to have a substantial impact on the future research of black hole theory. The holographic principle and ADS-CFT duality are two fundamental concepts in black hole theory. The holographic principle suggests that information in 3-dimensional space can be encoded on a 2-dimensional surface. This principle was discovered in the early 1990s as scientists explored the thermodynamics of black holes. A black hole is like a tear in space-time from which nothing can escape. However, black holes are known to emit heat. Scientists who have studied the thermodynamics of black holes have discovered that the laws of black hole thermodynamics differ from the physical laws we know. Specifically, they found that the entropy of a black hole is proportional not to its volume, but to the area of its event horizon. This implies that an infinite amount of information exists within the black hole. According to the holographic principle, this infinite information can be encoded on the 2-dimensional surface of the event horizon. In other words, all the information inside a black hole can be viewed through the 2-dimensional surface of the event horizon. The ADS-CFT correspondence is a duality between a quantum field theory in 3-dimensional space and a quantum field theory in 5-dimensional space. This duality was discovered by theoretical physicist Juan Maldacena in 1997. The ADS-CFT correspondence is closely related to the holographic principle. ADS-CFT correspondence, the quantum field theory in 3-dimensional space, can be seen as the boundary of the quantum field theory in 5-dimensional space. Therefore, the information in the quantum field theory of 3-dimensional space can be encoded on the boundary of the quantum field theory in 5-dimensional space. In black hole theory, the holographic principle and ADS-CFT correspondence are considered to play an important role in resolving the black hole information paradox. According to the holographic principle, all information within a black hole can be encoded on the 2-dimensional surface of the event horizon. Therefore, the paradox of black hole information can be resolved by explaining how the 2-dimensional surface of the event horizon changes when the black hole evaporates. ADS-CFT duality signifies a correspondence between a 3-dimensional quantum field theory and a 5-dimensional quantum field theory. Thus, it is possible to model the information inside a black hole with a three-dimensional quantum field theory. It is expected that through this modeling, new methods for resolving the paradox of black hole information can be discovered. Both the holographic principle and ADS-CFT duality are concepts that are not fully understood yet. However, these two concepts are believed to play crucial roles in black hole theory. Further research is expected to deepen our understanding of these concepts. The holographic principle and ADS-CFT duality are both essential concepts in black hole theory. The holographic principle proposes that the volume of three-dimensional spacetime can be encoded on a two-dimensional surface. This principle is considered crucial in resolving the paradox of black hole information. ADS-CFT duality involves a duality between a five-dimensional anti-de Sitter space, ADS space, and a four-dimensional conformal field theory, CFT. This duality provides a relationship between the thermodynamics of black holes and quantum field theory. The holographic principle and ADS-CFT duality are related to the simulation theory. Simulation theory posits that the universe we inhabit might be a computer simulation. While this theory is not scientifically proven, it has captured the interest of many people and has been explored in science fiction. According to the holographic principle, the three-dimensional volume of spacetime can be encoded on a two-dimensional surface. Although the method to implement such holograms is not yet known, computer simulation could potentially achieve this. ADS-CFT duality provides a relationship between the thermodynamics of black holes and quantum field theory. This connection can be utilized in simulating black holes through computer simulations. Therefore, the holographic principle and ADS-CFT duality can be interpreted as evidence supporting simulation theory. Of course, whether simulation theory is correct remains unknown and unproven scientifically. It is a hypothesis suggesting that our universe is a computer simulation, and the holographic principle and ADS-CFT duality offer theoretical bases that align with this idea. The simulation theory is a hypothesis that suggests the universe we live in could be a computer simulation. This hypothesis is related to black hole theory for the following two reasons. First, the black hole information paradox can be resolved if the universe is a computer simulation. If the universe is a computer simulation, the internal information of black holes could be preserved as part of the simulation. Therefore, when a black hole evaporates, the internal information does not need to return to the universe. Second, the ADS-CFT duality can be explained if the universe is a computer simulation. The ADS-CFT duality refers to the duality between a five-dimensional space and a four-dimensional space. This duality plays an important role in understanding computer simulations. Thus, the holographic principle and the ADS-CFT duality can be considered theories related to the simulation theory. Of course, the simulation theory is still just a hypothesis and has not been scientifically proven. The simulation theory posits that the universe we live in is a computer simulation. Although this theory has not yet obtained scientific evidence, it has become the subject of many science fiction movies and novels. The holographic principle and the ADS-CFT duality can be presented as evidence supporting the simulation theory. According to the holographic principle, the three-dimensional volume of spacetime can be encoded on a two-dimensional surface. This principle could imply that the universe we live in is a computer simulation. A simulation can generate a three-dimensional world on a two-dimensional surface. Therefore, according to the holographic principle, the universe we live in could also be a three-dimensional world generated in a computer simulation. The ADS or CFT duality can also be presented as evidence supporting the simulation theory. According to the ADS CFT duality, quantum mechanics in a five-dimensional space is equivalent to quantum field theory occurring in a four-dimensional space. This principle could imply that the universe we live in is a computer simulation. A simulation consists of computer hardware and software. Hardware is the physical device on which the simulation runs. Software is the program that controls the simulation. The ADS CFT duality states that quantum mechanics in a five-dimensional space is equivalent to quantum field theory occurring in a four-dimensional space. This principle could imply that the universe we live in is composed of the hardware and software of a computer simulation. Although the holographic principle and the ADS CFT duality are theories that are not yet fully understood, they can be presented as evidence supporting the simulation theory. According to the holographic principle, the three-dimensional volume of space-time can be encoded on a two-dimensional surface. Following this principle, all the past and history of humanity could potentially be encoded on the event horizon of a black hole in the form of infrared radiation, neutrons, or other forms of energy. Of course, this is still a hypothesis, and extensive research is needed to resolve the information paradox of black holes. However, if true, black holes could serve as colossal databases storing the history and culture of humanity. When a black hole evaporates, this information might return to the universe. While this possibility is fascinating, it remains speculative until further investigation occurs. Black holes are places where space-time is severely warped and nothing can escape, potentially allowing for the storage of all of humanity's past and history. However, a more nuanced response is, perhaps, the information stored in a black hole must adhere to known physical laws. Therefore, even if all of humanity's past and history were stored in a black hole, it might not be encoded in a way that we can read or understand. Information stored in a black hole could take various forms: infrared and neutrinos. Particles like infrared radiation and neutrinos can pass through a black hole. Therefore, all of humanity's past and history could be projected onto these particles and encoded in a black hole. Quantization of information. Information is quantized, divisible into minimal units known as bits. Even if all of humanity's past and history were stored in a black hole, it might be divided into extremely small units. Holographic principle. According to the holographic principle, three-dimensional information of space-time can be encoded on a two-dimensional surface. Humanity's past and history might be holographically stored on the event horizon of a black hole. None of these hypotheses have been scientifically proven, but they provide essential clues for resolving the information paradox of black holes. All of humanity's past and history may be projected onto infrared or neutrinos and reflected as information in black holes. According to the black hole information paradox, all information that falls into a black hole must be preserved within it. The interior of a black hole is a place where the known laws of physics do not apply, similar to a rift in space-time. Therefore, how information is preserved inside a black hole remains unknown. However, the holographic principle and ADS-CFT duality suggest that the information inside a black hole could be encoded on the event horizon. Infrared, or neutrinos, are particles that can pass through every part of spacetime. Thus, all of humanity's past and history could be projected onto infrared or neutrinos and reflected as information in black holes. Of course, this is still just speculation. The black hole information paradox is an unresolved issue. Therefore, whether humanity's past and history are reflected as information in the black holes will need to be clarified through future research. Here are a few hypotheses regarding the black hole information paradox. Information is destroyed. This hypothesis states that information is destroyed inside a black hole. Therefore, when a black hole evaporates, the information of objects that fell into the black hole is lost forever. This hypothesis violates the law of information conservation. So many physicists do not accept it. Information is preserved. This hypothesis states that information is preserved inside a black hole. Therefore, when a black hole evaporates, the information of objects that fell into the black hole returns to the universe in some form. This hypothesis adheres to the law of information conservation, but requires an explanation of how information is preserved inside a black hole. Information is transmitted to another dimension. This hypothesis states that information is transmitted to another dimension inside a black hole. Therefore, when a black hole evaporates, the information of objects that fell into the black hole appears in another dimension. Although this hypothesis has not yet obtained scientific evidence, it is considered an intriguing possibility. The paradox of the black hole, the paralysis of information, a symphony of simulation, the echoes of the final judgment, worlds where gateways open to dimensions untold, a cosmic intersection where reality and dreams unfold, the cosmic pathway leading to portals, endless alleyways of spacetime's stellar corals, a realm where existence and non-existence entwine, a labyrinth of information, a puzzle in the design, within the gaze of the black hole, distortion of time, the chaotic moment nearing the ultimate truth of the cosmic prime, thrills in the multiverse, the faint future of judgment, our destiny shrouded in mysteries, profound and abundant, dreams scattered at the infinite gateway, a nostalgic journey into the embrace of the cosmic array, the information of the black hole, the paradox of dimensions. In the cosmic puzzle, we encounter profound revelations. Thanks for watching.